This is how to derive pi by using Pythagorean theorem. I recently found out that this method is called the method of Archimedes, or the method of exhaustion. Just divide your circle up into 60-degree or equilateral triangles. The magic of an equilateral triangle is that every angle's 60 degrees and every side is 1. So radius is 1, and so is the distance from there to there. Bisect your triangle into a 30-degree angle right there, and then label it as A, B, and C. C will equal 1, B will equal 1/2 because it's half the distance from here to there, and then A, we have to solve for this just using Pythagorean theorem. The first calculation gives root 3 over 2. So once you solve for A, then you take 1 minus A to get this little section right here I labeled as A1. Here's the steps. First step is solve for A, just using Pythagorean theorem right there. Next step, solve for A1 by just taking 1 minus A. Next step, solve for C sub 1, which is this little hypotenuse right here. It's just A1 squared plus B1 squared, and take the square root of both of those together right there. And now that you've solved for C1, you simply turn C1 into B. So you take C1 divided by 2, and that'll give you your new B. C1 times 1/2 gives you the new B, and then you repeat the steps. Here's what it looks like. Right here, the C1 is a little hypotenuse from here to here. Redraw the triangle. Greatly exaggerate your angles so you can illustrate this better. That means this whole thing from here to here is C1, so B becomes half of C1. And then I suppose when you solve for that little hypotenuse that goes, this little triangle and that little hypotenuse right there, you could call that C2, I suppose. In the first case here, take 360 degrees divided by 30 for your angle. That'll give you 12. So that means there's 12 segments of this C1 right here. C1 times 12 gives you the circumference, approximately. Circ divided by diameter, in this case 2, gives you pi. And here's what it looks like. 360 divided by your angle theta times C1 over 2, or times C1 over the diameter to approximate pi. Just for a mental exercise, I thought it was kind of fun to put all of these equations into a spreadsheet to see how accurate I could get. Because once you solve for C1 here, then you cut it in half and it turns into B. It almost references itself, because then you use B and this distance here to get a new A, and then just keep repeating the process. Here's how to set up all the formulas. Once you type in the formulas across the top 1 or 2 rows, you just drag and drop all of them down. Takes less than 5 minutes, and you can get pi to the 1/billionth decimal place. And you can also find out where the computer can't handle any more decimal places right there. I was getting error messages up higher here and not getting very many decimal places. And then I remembered a little nuance with this computer is I can widen the columns and show more decimal places. Then all those error messages disappeared and I got a lot more accuracy. So here's the formulas. Just start with 30 and then divide by 2 all the way down, and then drag and drop all the formulas. And there's the formulas there. Number of sides is 360 divided by angle. Radius stays as 1. Side B starts as 0.5, as I showed on the diagram. A is Pythagorean theorem. A1 is just 1 minus A. C1 is Pythagorean theorem. The circ is C1 times your number of sides, which you got from your angle right there. And then pi will be your circ divided by 2, which is the diameter. Then the interesting part is you take C1 right there in column G, bring it back over here to column D where it says side B, and divide by 2. So take C1 divided by 2, and that'll give you a new side B, and then just same formulas all the way across.